Can we also compute an empirical estimate of the CDF from a sample? The answer is yes, and this is how you do it. Assume that we're given a sample with m random values. The question is, how do we find an estimate of the empirical CDF from the sample? The first thing we're going to do is to order the sample. So here we have first the minimum, then the second lowest value in the sample, the third lowest value. Here we'll just write a generic value in this ordered sample, and finally we have the maximum. For the values of the sample, we'll give the following estimate of the empirical CDF. For the minimum, we'll have 1 over 2m. For the following point, 3 over 2m, 5 over 2m. And for the mth value in the sample, we'll have 2m minus 1 over 2m. Finally, for the maximum, 2m minus 1 over 2m. Basically, the recipe is equivalent to assuming that at each value in the sample, we have 1/2 to the left and 1/2 to the right. What happens for values of x that are not in the sample? First, we'll consider out-of-sample values. So let's assume that x is smaller than the minimum in the sample. Our estimate of the empirical CDF for this value of x will be just 0. Assume now that x is above the maximum in the sample. The empirical CDF estimate for this value is going to be 1. For x that is neither a sample value or it is smaller than the minimum or larger than the maximum, so that x is between two sample values, we're going to do a linear interpolation between the corresponding values of the empirical CDF estimate for this point and for this point of the sample. This would be 2m minus 1 over 2m and 2m plus 1 over 2m, respectively. If we write the formula for the linear interpolation, we get this is a comparison between a log-normal sample in blue and the log-normal CDF in red. We see that the empirical CDF has the typical staircase form. Basically, it increases one step every time that there is a sample, and that it follows, except for fluctuations, the curve of the theoretical CDF.